Welcome back to Convert to Radians, a Pemberton Pre-Calculus podcast. Episode 5, Review Part 2. In this problem, we are given that the sine of an angle is equal to 3/5 in the second quadrant. Now, we know that in the second quadrant, sine is positive and cosine is negative. What we want to do is set up a triangle. Since we know that sine is opposite over hypotenuse, so from my angle's perspective, the opposite side is 3, the hypotenuse is 5. Since this is a right triangle, the adjacent side is 4 using the Pythagorean theorem. We can now write in all of the different trig functions based on this triangle and the knowledge that we're in quadrant 2. For cosine, cosine is adjacent over hypotenuse. The adjacent side is 4, the hypotenuse is 5. And since cosine is negative in the second quadrant, we get negative 4/5. Tangent is opposite over adjacent, which the opposite side is 3, adjacent side is 4. Tangent being sine divided by cosine, positive divided by negative makes tangent negative in the second quadrant. Cosecant, secant, and cotangent are just the reciprocals of sine, cosine, and tangent. So taking the reciprocals, we get cosecant of the angle is 5/3, secant of the angle is negative 5/4, and cotangent of the angle is negative 4/3. To find the exact values in a triangle, we are given that this side is 15, this side is 17, and this is the angle of interest. What you see written in red are what we can calculate. The Pythagorean theorem will give us that this side is 8. This now becomes the opposite side across from the angle. This is the adjacent side. This is the hypotenuse. Sine is opposite over hypotenuse. So sine is 8 over 17. Cosine is adjacent over hypotenuse, so it's 15 over 17. Tangent's opposite over adjacent, so that's 8 over 15. And then again, the reciprocals of sine, cosine, and tangent give us cosecant, secant, and cotangent, which is 17 over 8 for cosecant, 17 over 15 for secant, and 15 over 8 for cotangent. For this problem, we need to solve for x and y, the missing variables. Given this angle, to find x, I know the hypotenuse. I'm looking for the opposite side, so I'm going to use sine. The sine of 65 degrees is equal to opposite over hypotenuse. And thus I can set up sine of 65 is equal to x over 10. We're going to multiply both sides by 10. That gives me 10 sine 65. Make sure your calculator is in degree mode. It gives you 9.06. To find y, using this angle, y is the adjacent side, 10 is the hypotenuse, that uses cosine. The cosine of 65 degrees is adjacent over hypotenuse. If I multiply both sides by 10, I get y by itself. 10 times cosine 65, again in degree mode, your calculator will give you 4.23. For this problem, to find my two variables theta and x, this is a Pythagorean theorem problem. So 11 squared plus 60 squared is equal to x squared. I can solve this using the Pythagorean theorem. You eventually get 61. To find the angle, whenever we find an angle, the two sides that I know are the opposite side and the adjacent side. The trig function that uses opposite and adjacent in this problem is tangent. So the tangent of my angle is opposite over adjacent, 11 over 60. To find the angle, you use the inverse tangent. So inverse tangent of 11 over 60. Your calculator in degree mode will give you 10.39. To graph this trig function, we must identify the period, amplitude, phase shift, and vertical shift of the graph. The period of the graph for cosine and sine is always 2 pi divided by whatever the number is in front of my variable inside the trig function. Since this is pi over 2, we're going to divide by pi over 2. So 2 pi divided by pi over 2, flip the bottom fraction and multiply. 2 pi times 2 over pi, the pi's cancel, giving you 2 times 2 is 4. So we have a period of 4. The amplitude is 4. The amplitude is the number in front of the trig function. The phase shift is none because there is no parentheses and we're not adding and subtracting anything inside of a parentheses. And the vertical shift is also none because we're not adding or subtracting anything to the function. So now we're ready to graph. In order to graph this, we need to set up our x and our y axis. So in this case, since my amplitude is 4 and there's no vertical shift, I can go ahead and mark 4 and -4 for my amplitude. To find out what you should count by on the x-axis, you always take the period divided by 4. In this case, our period was 4, divided by 4 gives us 1. I'm going to count by ones on the x-axis. And I need 8 marks when I start. So 1, 2, 3, 4, 5, 6, 7, 8 gives me my 8 marks. When I graph cosine, cosine is high, middle, low, middle, high. And so starting at, since my phase shift is 0, I get to start at 0. So high is the high point of the amplitude. The next point is middle. The next point is low. The next point is middle. The next point is high. That's one period of the graph. Repeat. Middle, low, middle, high, and that's my graph. To graph this equation, again, period, amplitude, phase shift, and vertical shift. The period of sine or cosine is always 2 pi divided by whatever number is in front of the x. Since it's a 1, my period is 2 pi. The amplitude is the number in front of the trig function, which is 2. We do have a phase shift this time. What you do is you take what's in the parentheses and set it equal to 0. So for my phase shift, if I take x plus pi and set it equal to 0, solve for x, subtract pi on both sides, x is equal to -pi. This is now my new starting point. This is my phase shift. So my phase shift is -pi. And there is no vertical shift because on the graph we don't have a plus or a minus something outside the parentheses here. So using these 4 items, we're ready to try to prepare our graph. Since there's no vertical shift, my amplitude is 2. So from 0, I'm going to go up 2 and down 2 on the y-axis and make those marks. To number my x-axis, I need a starting point, and I need 8 marks after that starting point. Well, my starting point is going to be my phase shift, -pi. So my starting point will be here, and then I need 8 marks after this point. How do I know what my marks on the x-axis are going to be? We always take the period divided by 4, and that tells me what to count by. Since the period of this graph is 2 pi divided by 4, I get pi over 2. So I'm going to count by pi over 2's. So starting from -pi, I've got 1 mark. 0 counts as a mark, so that's 2 marks. And then 3 marks, pi over 2, 2 pi over 2, 3 pi over 2, 4 pi over 2, 5 pi over 2, and 6 pi over 2. So there are 8 marks counting by pi over 2's, starting at -pi and eventually ending at 3 pi. And this will be 2 periods of the graph. For sine, sine goes middle, high, middle, low, middle. And so starting here, middle, high. The next point is middle, here at 0, low, and then middle. And it repeats, middle, high, middle, low, middle, and that creates my sine wave of 2 periods. On this problem, the period, amplitude, phase shift, and vertical shift are as follows. The period of sine is always 2 pi divided by whatever number is in front of my variable. In this case, since it's a 2, I'm going to divide by 2. 2 pi over 2 is pi. That's my period. The amplitude is 3. You do not need the negative sign to describe the amplitude. The phase shift, there is none, because notice there's no parentheses with adding and subtracting in it. There is, however, a vertical shift of -3. We are subtracting 3, which is going to drop our graph down 3 units. So to prepare our graph, first of all, we need to know what we're going to count by. Since my period is pi, divide by 4. I'm going to count by pi over 4s. So I'm ready to set up my x and y axis. On the y-axis, since I'm going to have a vertical shift of -3, this is now my middle line here at -3. And my amplitude is 3, so I'm going to go up 3 and I'm going to go down 3 from -3. So my graph is going to fluctuate between 0 and -6. On my x-axis, I'm counting by pi over 4, so 1 pi over 4, 2 pi over 4, 3 pi over 4, all the way to 8 pi over 4, making 8 marks. Sine normally is middle high, middle low, middle. But if you notice, the original equation has a negative sign out in front, which is going to flip the graph over the middle line. So instead of going middle high, middle low, middle, it's going to go middle low, middle high, middle, whenever it's negative sign. And so that's why you see the graph of sine going down first instead. Middle low, middle high, back to the middle, and then low, middle, high, back to the middle. Our final graph is -2 cosine of x minus pi in parentheses plus 2. Period, amplitude, phase shift, vertical shift. We have all of these happening here. Our period is 2 pi for cosine divided by whatever's in front of the x. Since it's a 1, it stays 2 pi. My amplitude is 2. I do not need the negative sign, just 2. I do have a phase shift. Set this equal to 0 and solve for x. So my phase shift, if I add pi to both sides, my phase shift is pi. That's my new starting point. And I do have a vertical shift of 2 because of the plus 2 outside here of the trig function. So now I'm ready to set up my graph. For my graph, since I have a vertical shift of 2, the graph's going to move up here to 2 as my middle line. And the amplitude is 2, so I'm going to go up 2 and down 2 from this middle line. So my entire graph is going to be between 0 and 4. Since my starting point is at pi, I need to figure out what am I going to count by on this x-axis. To figure out what I count by, remember we take the period divided by 4. Since the period is 2 pi divided by 4, that gives me pi over 2. So I'm going to count by pi over 2's. So pi over 2, and then here's my starting point at 1 pi. From my starting point, I need 8 more marks, so counting by pi over 2's, I will get these values. 3 pi over 2, 2 pi, 5 pi over 2, 3 pi, 7 pi over 2, 4 pi, 9 pi over 2, 5 pi. This is where it's going to end for the 2 periods. Cosine normally is high, middle, low, middle, high, but notice that this graph is negative cosine. And because it's negative cosine, we're going to flip it. Instead of high, middle, low, high, it's going to go low, middle, high, middle, low. And now we're ready to graph. So I'm going to start at the low point, which is 0. My middle ground is the dotted line, which is at 2. My high point is at 4. Middle, low, finishes 1 period. And then middle, high, middle, low, finishes the 2nd period. And therefore I have my graph. This has been